Hello guys, welcome to Ace Coding. In this video, we are going to see the Leetcode problem number 1323, maximum 69 number. Let's get into the question. So the problem statement is, we are given a positive integer num consisting of only digits 6 and 9. You need to return the maximum number you can get by changing at most one digit, that is 6 can be changed to 9 or vice versa, 9 can become 6. So let's go on to the problem definition. Firstly, we'll define the problem. So define problem. So how can we approach this problem? The before approaching, we need to find the input. So input for the problem is integer n, and output will be maximum value after at most one change. Change is nothing but 6 changed to 9 or 9 changed to 6. This is considered to be the change. So, and they have also mentioned that the n will be consisting only of digits 6 and 9. So that's all about the problem definition, and let's approach the problem. So the brute force approach that comes to everyone's mind will be to to find the position of leftmost 6. So when we consider a number, let's call it 6, 6, 9, 6. So in this case, which number will you update to get the maximum value? So in this example, you can clearly see that you won't even change the 9 to 6, since it will be reducing the value. So when we change this 9 to 6, the value will be reduced up to 30,000. So anywhere you won't be reducing the change. So 9 to 6 change is not going to be done. So the only change we are going to do is 6 to be changed to 9. So we have known that we are only going to change a number 6 to, a digit 6 to 9 in the given digit. So we need to find at which position we need to change the 6 to 9. Which position to change. So how can we find this? So we'll try the brute force. So when we change the 6 to 9, there will be increment of say 3. In this case, the increment is 3, and when we change this 6 to 9, the increment will be 300. So plus 300. So in this case, there is 300, and when we replace this 6, the increment value will be 3000. So which will you choose, whether 3000 or 300 or 3? Which will you choose? We only choose 3000. 3000 is the maximum value, right? So this 6 will be chosen. So in this example, we can clearly see that we need to find the leftmost 6. Find the leftmost digit 6. Change it to change the 6 to 9, and finally return the number. So this is what we are going to do. If there are no 6 present, we'll return the num. So this is the approach for this problem. So how can we approach it? So brute force approach that comes to everyone's mind is to create a new character array or nums array. So we'll be creating a new array and storing each digit. So in this case, the value of 96696, right? So we'll create an array and store the digit. So 9, 6, 6, 9 and 6. So we'll iterate over the each value, I mean each cell, and when you firstly find the 6, we'll update the 6 to 9 and finally return the integer value of the array. This will take time complexity of big of log n, and space complexity also big of log n. So can we reduce this? The answer is yes. So how can we do it? Actually it's a pretty like a puzzle. So it's like a puzzle. So I couldn't able to find that puzzle. I got able to find it only after approaching the problem and finding it in the solution section. So how are you going to find that hint? So in the approach, how can you reduce the space complexity? So when you consider number 96696, so in this case we'll be updating this 6 to 9, right? So in this case we'll be getting increment of 3000. So how can we find this? It's nothing but when we find when we replace the 6, what will be the value? We'll get incremented 3. So when we replace when this by this 6, we get value of 300, and when we replace this 6 digit, we get value of incremented by plus 3000. So these are the incremental value. So we can keep track of maximum incremental value. So we'll keep track of maximum incremental value, and finally we'll return number, given number plus maximum incremental value. So this is the approach we are going to use. So how to approach this, you will be very clear in the coding section. So yeah, let's get into the coding section. Firstly, you'll have let's call a variable called int value. We'll have it as 0, and we'll have a temporary we'll have a variable temp which will store now, and we are doing this to approach is nothing but firstly find the maximum incremental value. Second step is going to be adding the number with max incremental value. So that's it. So when temp not equal to 0, so initially we'll find the remainder. So remainder will be temp mod 10. So we also have a rank value as firstly initially the rank will be 0. So let's consider this example. So in this case of 96696, the rank of each digit will be 0, 1, 2, 3, 4, etc. So we have the rank as 0. So if remainder is equal to 6, we'll update the incremental value by 3 into let's have a function. So I have a helper function called a multiple, so mul10, which will multiply the 10 by number of 10. So it will pass the rank. So each time we'll when we meet with digit 6, we'll update the incremental value. So we'll write the helper function later. So after that we'll be dividing the temp by 10 and increment the rank. So that's it, and finally we'll return the number plus inc value, incremental value. So we'll write the helper function int mul10 of boolean. So here we'll have uh, so actually we have 3 plus multiple options. So usually we'll have if n is 0, we'll return 0, or else we'll have a value called let's say 1 int and is equal to 1, and while n greater than 0 and into equal to 2. So now we will return the answer. So this is the helper function. The helper function will multiply n, that is 10 by rank number of time, but if the rank is 0, we will be returning 0. So actually we need to multiply this. So actually what are we doing here? So let's check it. So in this case the rank will be 0, so incremental value will be 3, right? So how will we get the 3? So it's nothing but 3 plus sorry 3 into mul10 of rank. Mul10 of 0 will be 0, so 3 into 0 will be 0, and plus current value 3. So when we come to here, the rank value will be 2, the incremental value should be 300, right? So how will we get 3? How can we get 300? It's nothing but 3 into mul10 of 2. So mul10 of 2 will lead us to 100. So 3 into 100 will lead us 300. So this is the approach we are going to use here. So 3 into mul10. So yeah, finally I will return the incremental value of this number. So let's check it out. Actually we haven't divided the n by 10. So why we are doing this? Initially when you have digit as let's say 1 2 3, initially this when you have n as 5, we need to reduce the n. So for 5 times will the loop will run. Yeah, so we'll check it out. So we got a wrong answer. So in case the rank is 0, if rank is 0, we'll have incremental value as 3, or else we have incremental value as right. So we can have just change in the my helper function mul10. So n is equal to 0, we return 1. So we don't need these extra statements. So I set it up. Working fine. Let's submit it up. Accepted. And the time complexity of approaches of log n, and the space complexity is of which is constant, and the approach for this problem is um, mathematics. So that's all about this video guys. Thanks for watching this. Have a great time.